In this session, we'll talk about one alternative conditional statement. Before that, we need to talk about Boolean data types. A Boolean data type can take on the value of either true or false. Here, I'm going to declare two Boolean data types, B1 and B2, and assign to them, let's say B1 is equal to true, the value true, and assign to B2 the value of false. And then I am going to write out those values. Let's say B1 and then a bit of space and then print B2 and line return 0. When I run this program, the value of B1 and B2 are going to be printed, displayed on the screen. 1 is equivalent to true. Internally, true is represented by 1, and false is equivalent to 0. So internally in the machine, false is 0. So those are Boolean data types. They can only take on the value 0, 1, or false, true. Now with that said, we can talk about relational operators. Relational operators in C++ are the greater than, less than or equal to, greater than or equal to, equal, which is made up of two equal signs, and then not equal, which is exclamation mark equal. Those are relational operators that we use in C++. And using those relational operators, we can create Boolean expressions. For example, I can say B1 is equal to, and have something like 5 not equal to, let's say, 6. The right-hand side, this is an assignment statement, line 12. The right-hand side is a Boolean expression, right? That's a Boolean expression. When you evaluate it, the value of it is either true or false. So right here, you're checking to see, is 5 not equal to 6? That is true, and that will be assigned to B1, which is a Boolean data type. So if I print the value of B1 once again, you will see that it is true because we just assigned 5 not equal to 6, which is true, to it. So let's run this one more time. You will see another 1 printed. That's true. Now, if I change this Boolean expression to 5 equal to 6, that's false. 5 is not equal to 6. So this Boolean expression is basically evaluated to false, and false is assigned to B1. And when I run it, I get the value 0 for B1. Okay. Now we can move on to conditional statements. One alternative if statement. One alternative if statement. Here is the syntax of it. You start with the keyword if and then some Boolean expression, right? Let's say before we start this conditional statement, let me declare a variable x as an integer, and then prompt the user to enter a value, an integer value for x, let's say, right? And then read it. Cn and read it into x. I don't need to specifically say for x. Just read enter a value, an integer. This makes more sense. Value. You read it into x, right? And now I'm going to create a conditional statement. If x is greater than 10, so this is a conditional statement. If x is greater than 10, if that's the case, this block of code will be executed. And what is the block of code? I'm going to say cout the value entered is let's say greater than 10. Right? Just a message like that. Nothing technical really. And then outside the block, I will continue and say, okay, here's another integer y, which is equal to, let's say, 5 times x, and I will print the value of x and y together at the end. So that's y is 5 times x, and here it is, cout x is equal to the value of x, and y is equal to the value of y. There you go. That's our program. Now, let me get back to this conditional statement. That's the main topic of this lesson, really. The conditional statement, OneAlternative, works this way. Start with the statement if, with the keyword if, and then followed by a Boolean expression inside parentheses. That Boolean expression is either true or false. If the Boolean expression is true, then the block of code immediately following the if statement will be executed. If the Boolean expression is false, that block of code is skipped. So this block is executed if the expression is true. If the Boolean expression is true. Which Boolean expression? The Boolean expression right here. I can actually say the Boolean expression x greater than 10. If that's true, then the block is executed. If not, the block is skipped. Right? So let's run this. We'll try it out. Enter an integer value. Let's enter a 7. Now, is 7 greater than 10? That is false. So this block, line number 20, will not be executed. The program will skip it and continue with multiplication of 5 times x and the final printout. So 7 is entered and no message. This message is not printed, as you can see. It's skipped. That one. It's skipped. And then what happens? Y is declared. It's initialized to 5 times x, which is x is 7, that's 35, and then x and y both are written. So if I try it one more time, but this time around have a number greater than 10, let's say 11, now you see that message executed. So the block is executed, the code inside the block is executed, the value entered is greater than 10, x is 11, and y will be 55.